can use that
Yeah,
as well.
thank you. Just got to position my microphone so I don't have to lean over the whole time, but can everyone hear me? Great. So my presentation is about OpenSearch and some of the geospatial functionality in it. As I mentioned, I'm a senior developer in Earth observation applications and a lot of other stuff at Frontier SI. I didn't really fill out my bio into much detail for this conference, so just thought I'd briefly mention some of that. I'm from Melbourne, Australia. This is my first FOSS4G event, but I've been a long-time follower, so I was really excited to be here and get the opportunity to listen to so many wonderful presentations, workshops, and just talk to a lot of different people. I think I've talked to about 50 people this week at length, not just 2 minutes and high, so it's quite overwhelming, but also wonderful. I spent a bit of earlier part of my life in X-ray physics, where I was processing raster data. That's X-rays, not X-ray, which I've heard a lot about and use now. I programmed in Fortran. I also use MATLAB and IDL, which are enterprise kind of softwares that you might not have heard of IDL, but it's an image processing packaged type software. I've had a very long interest in Earth observation data with doing X-ray image analysis and processing. I always thought that was like an application of the work I was doing there, but it's at a very different size scale, going to the atomic scale, you know, compared to land, trees, the Earth. A project I got involved with a friend, colleague from my physics days, she started this toy catalogue software called Settles. Yes, it's a bit of a weird name, but it was all about getting the right domain name, which is very hard to come by. So the acronym stands for Serious Toy Library Software. Toy libraries are kind of a sustainability thing where you borrow toys. If you've never heard of toy libraries, it's like a book library, but you borrow toys. The software has a catalogue of the toys, does member management, and I got my hands dirty in full stack application development working on that. We deployed on AWS. I learned Ruby on Rails. We used some Google Maps stuff in there. And then Leaflet, we eventually sold it about 4 years ago. And there was a pretty good uptake in New Zealand. So I've got a little map from the Settles website showing the locations of where some of those toy libraries that use the software that we worked on use it. In software development and engineering roles I've worked across bioinformatics pipelines, LiDAR processing and visualization. As a geospatial consultant, a DevOps engineer, I've tried to stay close to something scientific. Geospatial is rich in that, obviously, which I really love. And so I'm very happy to be an Earth observation developer at Frontier SI now, where I get to touch a lot of that stuff. So I'll just hit the question, what is OpenSearch? It is an Apache 2.0 search and analytics engine based on Apache Lucene, which is an open source thing. It was a fork from Elasticsearch that you might have heard of in your time. I've certainly heard of it in my time without knowing what it was, but now I do. Elasticsearch changed their licensing at that time, and AWS wanted to continue using it. They created the fork and made the OpenSearch project as a community open source project, and it's been going since then, 2021. And it's fully open source, and there's now the OpenSearch Foundation. It's part of the Linux Foundation and all this wonderful stuff. There is also, of course, an AWS integrated and led offering of OpenSearch, so you don't necessarily need to be a developer or a DevOps engineer to use it. And if you've experienced the nitty-gritty details and pain of setting up the infrastructure of it, you may want to go down that path if you're looking at implementing a logging and observability solution in your cloud platform. So there's multiple components to OpenSearch. There's the database in terms of the Docker containers or the containerized parts of it that work. Thought of as nodes that hold the data, ingest the data, and where the data is indexed. There's OpenSearch dashboards that acts as a front end to controlling those nodes in the cluster. You can control the settings, configure it, and it has really good visualization tools within it to create some pretty awesome dashboards. There's also OpenSearch Data Prepper to help get data into your OpenSearch observability platform. There are other ingestion services to deal with. For the logging and observability case, you might be streaming very high throughput logs at fine time intervals, and these other tools help you get that data into OpenSearch to analyse. And then you have to figure out what to do with it when you've got too much of it, then you don't need last year's logs or whatever. So that's another problem. And there's a whole bunch of plugins for OpenSearch that have been developed. Many of these might mirror what's going on in Elasticsearch, because why not do all the same stuff, but do it open source? Okay. So for cloud architecture, I created this diagram with Microsoft Copilot. But I wouldn't say it's typical, but it puts some things that look like Lambda. They're not really Lambda functions, but shows the kind of mess and complexity of how difficult that structure could be to find out what went wrong when something did go wrong. Was it your database? Was it your front-end application? Was it your back-end application? Was it some messaging service or a Lambda function? Is the network down? How do you get to the root cause of that information? With a tool like OpenSearch, you can instrument the logging and metrics collection from all those different parts and get a nice overview of what's going on. OpenSearch Dashboards has a great tracing feature where you can get a node, I'll show it in a minute, a node graph to look at which parts, what they're doing, what parts feed into the other, and look at some of the stats on those and get a good idea of how your system's performing and act on those by identifying the root cause. At a previous organisation I was working at, we were implementing this as our observability solution. It was a space company called Sabre Astronautics, and many people here in the Earth observation community and sometimes forget about that, the other side of the picture, not taking the images of the Earth, but who is taking them and how is that being done. It's becoming a mess up in space. There's like 40,000 plus satellites orbiting the Earth. These pictures on the right-hand side of the screen, there's a lot of providers out there that show the status of satellites up in the sky in near real time that are getting data from some API that records it. And on the first image at the top is like there are little red dots, which is the high Earth orbit regime, and then as you zoom in closer to the Earth, you've got medium orbit, and then you've got low Earth orbit as well. And amongst the satellites, there's also space debris, there's bits of rockets, there are things that have crashed and they're just there floating around. So if you're flying a satellite and controlling it up there, you have to continuously monitor how the satellite's going. The satellite needs uptime. It needs to be aware of what other satellites it might collide with so that you can slightly remaneuver the orbit to keep going. And in addition, the satellite itself has a lot of components and hardware on top of it. Could be upwards of 10,000. Each component will have a fallback component. Those components are emitting data to a telemetry that eventually will get received at regular intervals when your satellite is passing over a ground station that is hooked up to your software control system. So it gets pretty complicated. You need some decent observability platform to control it all, and I only imagine the case is far more complicated for a constellation of satellites like Starlink and Planet. And this certainly was offered a vast improvement upon using CloudWatch logs as our software was implemented on AWS, or CloudWatch dashboards, which it has some functionality, and CloudWatch insights. And I think, like AWS is aware, those things are hard to use when you need to get them all together. So that's why they have an OpenSearch offering themselves to implement this for you. So just a couple of images. On the left shows what the traces look like. On the right shows an example of what the dashboards look like with really beautiful visualizations. So I'll just get into OpenSearch. So I've got some tabs open in my browser which show what it is. So there's this public OpenSearch website called playground.opensearch.org where you can log into it, you can check out all this different functionality. You can edit settings, basically a playground. You can really see the cool stuff that it's got. It's got pre-populated example data that you can explore how to create change visualizations, see what they can possibly look like. This is just an example of exploring some of that data, showing counts of something against the logs that were directly being generated by it. This is an example of the tracing feature, where if you've instrumented the data that you're generating for logging and observability in a particular way, there's a particular format it's got to be in, you can generate these node connection graphs that show how the different parts of that application work. And although this example here doesn't say, it's giving me no red alerts, but you can determine what's going wrong in that structure. So it's a really good feature that's not directly implemented in CloudWatch logs. So it's here. This is an example of showing just a little bit more of the visualizations. Any typical data visualizations that you know of, you name it, it's probably got it. They look really nice. This doesn't show everything, but just shows some of it. It's pretty cool. I've sometimes worked on data visualization stuff at the coding level, and being able to drag and drop and create things from a tool like this is just really awesome if you don't have the time or it's not your current purpose. So what makes it different, or how is data stored? In the Lucene database, it's not a relational database, which the sort of structure there is tables with rows, and a single object might be represented across different tables, and they're linked by shared attributes and primary keys. And those types of databases are good for structured data that can be modelled by those interconnector relations. In OpenSearch, it's in the document-oriented database category, NoSQL. Every piece of text in some unstructured entry is inserted into an index, and that lends itself to some really cool functionality with vector embeddings, which, to the root of OpenSearch, has search in the title. It is actually quite a lot about the search functionality of it. I came into this software for the logging and observability case, but the search is really powerful. I had the opportunity to go to an AWS OpenSearch roadshow day and learn and see a whole lot more that this side of it can do. There's personalised search, of course, because AWS is Amazon, they want to sell things. Personalised search, get the product right in front of you. They've got great algorithms, ways to embed LLM models into the system to basically increase the performance of the search and get the right things in front of you. They showed semantic search, how you would set that up using embedding models. Semantic search extends beyond lexical search. Instead of finding exact matches in a string of text, you can find similarities and basically yield more results, just find more stuff. It's really great. And then there's what's called multimodal search, again using embeddings, but you can add images to your searching. You can find, if I wanted to find that whiteboard duster right there, if I wanted to find a shop that sold that exact one, I could put a picture in and somehow find the results in a catalogue of ones that kind of match that thing. And of course there's generative AI in it, which I didn't see too much of, but it's there, it's happening everywhere. One of the ways OpenSearch software is designed, by design, it is a distributed database structure. You have the data stored on a cluster of nodes in which the documents that are ingested into the database are sent to an index. The index is comprised of shards. There are default settings with how the sharding works. You can alter them or preset them when you're creating a new index. The shards are distributed to nodes. So in this sense of this diagram, you've got an OpenSearch node 1, node 2. You can keep adding more nodes to whatever your use case is. It's designed to be fault tolerant and resilient database. If you wanted to tinker with OpenSearch, what would you need to do? I've got a picture on the right-hand side of a snippet of a typical Docker compose file, which is a YAML file structure that shows some of the things you might need to set up. I'm not going to go into detail there, but my summary here is it's not for the DevOps weary. It involves Docker Compose. You could do it with Kubernetes. There might be some scripting, Helm charts. You'll be dealing with configuration files. There's a lot of complicated configuration to go into to your heart's content, depending on your use case and how much is your infrastructure team got to be putting effort versus using a paid solution provider like the one that AWS does. If you wanted to contribute to the code, it is Java. Not many. I've seen a lot of Python talks here. Haven't met many Java engineers. Someone was saying to me yesterday, this Apache Lucene is going to be, basically Rust is going to take. There's going to be a Rust something. So I don't know where it stands. Then there are also the things that get data into OpenSearch that process at high throughput the data that comes in. Two of the ones that I played with were Logstash and FluentD. Logstash is Ruby, and I was familiar with that from Toy Library software. So that lent itself to making changes and configuring it to my specific use case. I guess if AI assistants are already your best friend, that can certainly accelerate the process of running this yourself, getting it up and running, tinkering and whatnot. And of course, as I showed, there's the Playground website that you can tinker with the dashboards and look at the other plugins. So just a recap of the applications. Observability, logging and monitoring and tracing, that was how I came to this software. The analytics dashboards, which are wonderful. Cataloging of data makes it easier to search for relevant or related data, in which I saw a talk yesterday, Alex's talk. They're using Elasticsearch, and I saw the very improved Australian Ocean Data Network catalogue that he demonstrated that use case. As an extension to observability and logging, there's security analytics. So you could use the logging to detect security events. And use machine learning to see what the baseline of your, safe security of your system is, and be alerted to when there are security events. And additionally, just finding ways to do things with unstructured or semi-structured data. That's kind of an open-ended comment at the end there, really. So show me a map already. This is supposed to be about geospatial stuff. I will show the map in a minute, but just to the dot points I've got here, it does have maps for visualization. There's potential to do indexing and querying on that maps feature, and the data that gets ingested into OpenSearch can have XY coordinate data. It can also have geospatial shape geometries like polygons. It's not extensive, it's a little bit limited. Elasticsearch might have more than what OpenSearch currently does, but OpenSearch will definitely be pushing to mirror the same stuff. You can configure map tiles, so it comes with a pre-configured WMS layer for the map, but you could put your own in. And you can also upload custom vector data as a GeoJSON something, but it has to be in the 4326 projection. So I'll just show some of those maps. Again, in the Playground, there's some pre-loaded data sets. One of them is this flight status dashboard. I guess it's not live data. It's not actually live data or anything, but it's got a mapping dashboard, a dashboard of the airport locations around the world. I don't know how detailed, or how many it actually shows. You can zoom in, you can zoom out, obviously. You can add different geospatial layers. The layers have to be an index that has geospatial data to appear on the map. On the right-hand side of this screen, you've got those functions where you can draw a rectangle and do some of the data queries based on what's matching inside that rectangle. So at the top, I've just applied a new filter that's now honing in on this data. And you can draw polygons to do similar sort of thing. And I just wanted to double check that there's a dashboard for the airport stuff as well that might have a little bit more. A lot more data visualization, and I remember scrolling down this page just shows like the beautiful data visualization. And again, another map. And I haven't explored everything that it's got, but it's got a lot of stuff that you can do, which is, it's really cool. Other geospatial OpenSearch projects that I've come across as I was researching this talk. There was a paper published in 2017 making OpenSearch a standard for disseminating Earth observation data. Worth a read, relevant to me researching this. GeoSolutions, who have been sponsoring at FOSS4G and have presented their work on integrating that very thing. There's an OpenSearch Earth observation plugin for GeoServer, which I've looked through the documentation, looks pretty cool. Love to try it out. There's also, in the Stack GitHub repo, there's a utility for Stack Fast API that interfaces with both either Elasticsearch or OpenSearch, and that it creates an API to serve Stack catalog data that's been ingested into your very powerful Elasticsearch database or OpenSearch database. And I just quickly came across this website, that the guy that contributes to that Stack Fast API thing, he's got a map. This is a separate front-end thing, but it interfaces with that. And I'm just watching the time, but I've only got like one more slide. It interfaces with various Stack indexes, and you can do some of that querying with bounding boxes, rectangles, and see what Stack data is available within a particular provider and region that you're looking at, which I haven't loaded up on screen, but it's in a link to this document. So what else could you make? So as I'd worked on it and I'm interested in Earth observation, that's what I was kind of thinking about, the cataloguing ability of it. OpenSearch has a really powerful search functionality, and it's got a dashboard functionality, so you could do quite a lot. I was thinking data from Earth observation catalogues or providers that aren't adhering to a particular standard, they might non-Stack or non-OGC, aerial imagery provider that hasn't gotten onto some standardized format. Perhaps you could ingest all these disparate data sources and have some more powerful search functionality in finding relevant data sources that you need to analyze. Coming from a bioinformatics pipeline background where you're processing data and the way that you're QCing the process and monitoring the process is very driven by looking at a table, data that feeds into a table. You can see this is passed, this is passed, this is passed. I think you could most certainly instrument your processing pipeline to feed your logging into OpenSearch and use that maps feature to show your geospatial progress on how your pipeline is going. Someone earlier talked to me about Argo. I'm not sure if it's got that kind of feature. There's all these orchestration platforms, but I'm not sure if they've got this kind of use case there, but I think it could definitely be integrated here. And image search, obviously with Earth observation data, aerial imagery data, their images, they're much bigger files. I probably wouldn't want to chuck a 30 gigabyte GeoTIFF into OpenSearch and try and find another one that was related. But certainly for smaller size, low resolution thumbnails or something, perhaps you could use an embeddings model to find related imagery data just based on the image. That seems like something exciting to explore. And just harking back to my toy library catalogue days, which our library was a relational database catalogue, which is not very extensive. I went and checked. I thought about the book library that I use and how difficult it is to always find the book in book form of something that I just enter the title in, and it is broken. There's something very broken there. A book title I was looking for, knowing that the catalogue will never give me the physical book as the first listing. It gives the ebook, the DVD, the other titles related. So then I put book with my search and still yield 52 results that weren't the book of in fact the book just didn't even show up. So something is broken in whatever they're using to power their search function for their catalogue. Yeah. So thank you for having me. Thanks for coming to the talk. And all the volunteers and sponsors and everyone at FOSS4G. This has been a great conference to come to. Any questions?
Thank you very much, Rebecca. Any questions for her? comment.
Thank you. Yeah, great talk. Can you go into any more detail on why you choose OpenSearch over Elastic?
Because of open source. So at the time, it was, just the open source. Yeah. I spoke to someone yesterday who was a formal principal engineer at Elasticsearch, and he said, why don't you just talk about Elastic? It's changed the licensing again. But yeah, very much for the last 3 years, whatever, it hasn't been open source. So. But I've heard the providers that provide it are very good. Anyway, so.
Any more questions for Rebecca?
So this isn't a question, but I do know that for OpenSearch, there is operators for Kubernetes to make it a lot easier to manage, and there are, I believe, Helm charts for it as well. But there is a big operator if you get into the Kubernetes realm for it. It's got some problems, but it's all right. Yes,
there's definitely the Kubernetes. In the Docker Compose, I mean, I had to deploy this without Docker Compose onto a clustered, like Amazon ECS. So because just of the nature of dealing with clustered deployment, you see all that stuff. We could have done Kubernetes because it has all those templates as well, but it's certainly there, probably easier than what we were trying to do on ECS.
Okay, thank you very much. Any more questions? I think we are all hungry already. So again, a big applause for Rebecca, please.